Pinecone, LangChain, and OpenAI are some of the hottest technologies in play today. And in this video tutorial, I'm walking you step by step through how to build a chatbot that uses all three. Let's get started. We are going to ingest and process every single post that exists on my blog. Let's start by looking at the LangChain docs. The first step in preparing our knowledge base is to load all of our documents into memory. And in LangChain, these are known as document loaders. Once the documents are loaded into memory, we then split them. And just as this diagram shows, we are literally splitting each document into chunks. If you think about a given page of a chapter or textbook, there might be many different things that chapter or textbook talks about. So by splitting the source data into chunks and then embedding those individual chunks or converting them to vectors, we get more granular with our data. And that's what allows an end user to ask a question of a RAG or AI-backed pipeline and get a scarily good answer, like an extremely accurate answer. So now we've seen how our data gets into our vector store. How do we ensure that our chatbot can use that vector store to answer questions correctly? In the retrieval phase of retrieval augmented generation, the end user is asking a question, and we first go through a retrieval phase. This is our vector database essentially examining all of those chunks that were converted to vectors and trying to search for the most relevant chunks. And you see these blue hits are essentially the chunks that have been found that are semantically the most relevant to the user's question. These relevant chunks will be provided and wrapped in the prompt at generation time. So this whole process is happening essentially in a second behind the scenes before the chatbot answers the user's question. With that preamble out of the way, it is time to start coding. So we're going to build our chatbot that uses Pinecone, LangChain, and OpenAI. All right, so first thing that we need to do is get our data source, and in this case we are going to use my blog, and luckily my blog is completely open source. We're going to first pull down and clone my portfolio site, which contains all of my blog posts. At this point, with a single command, what we've got is my portfolio website, and we can actually look at the entire contents, and let's do that real quick. We'll step into, this is a Next.js app and blog, and it uses the app router. So you step into circ and then app and then blog. You will find all of my blog posts. Each blog post has its own subdirectory. Underneath each subdirectory, you'll notice there's a page.mdx file. Every single blog post is essentially this, a page.mdx file that lives under my blog directory. Great, so now we have our data. The next thing that we want to do is install all of the dependencies that we're going to use. There's LangChain community, LangChain Pinecone wrappers or interfaces into Pinecone's SDK. LangChain OpenAI, same thing, but for OpenAI. Unstructured is an API and a service that will clean your unstructured data regardless of the format that it's in. Very handy. And then LangChain text splitters, which is one of the tools that's going to perform that chunking and splitting that we just talked about. The next thing that we're going to do is import the tools that we're going to use. And Pinecone Vector Store is a LangChain class that wraps a Pinecone vector database. And as we're going to see here, using the various tools from LangChain can be excellent time saver. Okay, so I just imported a directory loader, and notice it's coming from LangChain community, document loaders. And so if you think back to the diagram that we looked at with LangChain, this is going to accept a single directory. You can maybe guess which one. And it's going to read all of the files that it finds under there and then load them into memory. And we'll see how that works in just a sec. And then after we've loaded them, we are also going to need to split them. Also need the OS module, and we need the glob module. And we'll run these to make sure everything looks good. Okay, cool. Our loader is a LangChain directory loader. And the way a LangChain directory loader works is that your first argument to it is the name of the local directory that you want it to load. And so as we can see here, if you expand this content or file system button on Colab, you get portfolio. This is indeed the website that I just cloned. It's my website. We're going to ask it to look into portfolio, and then what should it do when it looks into portfolio? Well, we actually are going to give it a glob, and a glob is a file matching pattern that's very powerful and expressive. And so by doing this, we are saying, look in the portfolio directory, look under all subdirectories that you need to until you find any and all .mdx files. It's going to look under circ and then app and then blog and then 2023 wins, and it's going to read this page.mdx and load that into memory, and it's going to then proceed down and do the exact same thing with this post and all of the posts. And we'll see if we run this, we've got the loader set up and ready to go, but our documents are not yet actually loaded in memory. To actually load our docs into memory, we run loader load. You can also hit Control Enter instead of clicking to run a cell on Jupyter. And a lot of folks don't know this. You don't have to type out print and then docs if you don't want to. In a Jupyter Notebook, you can just do docs 0 and say, give me the first document. And if we do that, we can see that this is now a LangChain document, and that has an attribute of page content, and I recognize that this is the raw MDX file that I wrote. And so this is one of my blog posts, and so that looks good. This is working. So at this point, we have all of our documents loaded into memory. The next thing that we're going to want to do is set up our OpenAI and Pinecone API keys. I'm going to show you what that looks like all the way end to end using Pinecone. If I come over to my Pinecone account, which you can reach by going to app.pinecone.io, I'm going to come into indexes and then create a new index. We're going to call this, let's call it Pinecone Chatbot. The dimensionality is going to be 1536, and that's because I know that the text embedding model I'm going to be using, which is OpenAI's text embedding 3 small, outputs a dimensionality of 1536. I'm going to use serverless. Serverless is now generally available for all Pinecone users, and essentially it separates storage from compute. So the nice thing here is that you no longer need to specify or understand the size of your workload up front. You don't need to know the total number of vectors that you're planning to store. You can just start storing, and then Pinecone will scale infinitely under the hood for you. So I'll create index. It's going to take a little bit while that is initialized, and no records yet. That's fine. It's completely empty. And then I'm going to go over here to API keys, and I'm going to go over here to API keys. I'm going to create a new API key. We'll call it Chatbot. And I'm going to copy my new Chatbot key. And I'm going to come over here, and let's just pretend that my Pinecone API key doesn't exist yet. So I'll do Pinecone API key, plop the value in there. And then you need to hit this toggle, and this is what says that your notebook code is allowed to access this environment variable and to read its value. Do the same thing with my OpenAI API key. You could get that from your OpenAI dashboard and provide it in the same way, and then check it so that your notebook has access. The last important thing to note is that when you're here in the secrets panel, you can see that Google provides you with the snippet to use to read a given secret name, and that's exactly what we're going to do, because we need both our Pinecone API key and OpenAI API keys available and accessible to this notebook. And we're just, because the libraries, both OpenAI and Pinecone, expect to read this environment variable by default out of the environment, I will put it where they're expecting it, like so. And the same deal for the Pinecone API key. And let's run that and make sure that it works. Cool. Okay, we have our secret set up. The next thing that we want to do is initialize our embeddings class so that we can pass text data into OpenAI's embedding model and get back vectors. First, let's get our embeddings class set up. And we're going to use, as I mentioned before, text embedding 3 small for this. This is the latest as of the time of this video creation. This is our embeddings class. We're going to create a variable to point at the Pinecone index, and we named that Pinecone Chatbot. And now we're ready to split our documents into chunks. First thing we need is a text splitter, and LangChain luckily has that. It is a recursive text splitter, and then we're going to do exactly that and split our docs, but the method is actually split documents, and we're going to pass in our docs that we created with our loader. So let's fix our OpenAI API key name, Pinecone API key. Let's try this again. And try this again. Okay, and so now this works. So we now have an embeddings class, we have an index name variable, we have a text splitter, and then we have split docs. And we do indeed have a chunk. So it is the same document that I saw before. Let's see what happens if we just do 25. Yep. And so we get a different chunk, but the idea is that now split docs contains the chunked documents, so the chunked blog post from my site. All right, very exciting, and now we are ready to create our vector store. And a vector store is a Pinecone vector store from LangChain using the from documents method that takes in split docs, embeddings, and index name. And now LangChain is going to do all the heavy lifting for us. If you are perceptive, you might notice that underneath here you have a little bit of executing, and we can see kind of like a collapsed code tree of what's being executed. There's a bunch of embeddings happening behind the scenes. So by passing in your split documents, your embeddings class, and then the index name that you want to use in Pinecone, LangChain is essentially doing all the heavy lifting for us. And this neat variable that is returned at the end is our vector store. And the vector store is useful for a variety of different things in the LangChain ecosystem. We're going to use it as a retriever. Because I know my writing well, I will say, ask a question, what is the programming bug, which is something I wrote about only in one post. If we do similar docs is equal to vector store similarity search query, exactly. Thank you, Google Colab. Someone's paying attention tonight. If I now print similar docs, what I get back exactly the chunk that I expect, because this is the exact chunk where I defined the programming bug when I was writing this blog post. I would say that this is a successful test. Our vector store that we've created with LangChain is now returning highly relevant documents based off of queries. So that's great, but there's one more step to go if we want a true RAG chatbot. So we have our knowledge store that's backed by a Pinecone vector database. And then our QA chain is essentially what Colab has also suspected correctly here. And so it's a retrieval QA from chain type, LLM equals LLM, chain type of stuff, and retriever is our vector store with the as retriever method called. So what this code is doing is building a full RAG pipeline in a few lines of code, and using ChatGPT's 4.0 model, using our vector database that we just created, we can now ask this chatbot questions. And if we ask what is the programming bug is described as the spark of innate curiosity that drives your learning forward. And with that, we've created a chatbot that uses Pinecone, LangChain, and OpenAI to do retrieval augmented generation on top of any arbitrary data source. If you enjoyed this video, if it helped you in any way, I hope you'll give a like and subscribe. I'm creating tons of content about machine learning, AI, and vector databases, so I hope to see you in the next video.